Hey, it's good to see you. I was just about to start on my next challenge. I'm supposed to use this model to calculate the height of this building. Can you help me? So this is the Burj Khalifa, the tallest building in the world. The note says, the tallest tower isn't slight. Use the model to find its height. The digits reveal the pieces you seek. Just find the height from its base to its peak. Seems like we'll need to solve these equations to find the height of the actual building, so I guess we can just get started with equation number 1. At least, I think this is an equation. It has an equal sign and a variable, but why does it look so different? Oh, you know what? This is a special type of equation called a proportion. A proportion is an equation that is made up of two equal ratios. Basically, both sides of the equation are fractions, and the two fractions are equal to each other. I think we can handle this, just like the other equations we've been working on. Let's give it a try.
3/8 is equal to a over 44. What is happening to a? A is being divided by 44, so how can I undo division? Exactly! I need to multiply both sides by 44, which will cancel the division and get a by itself. Since I'm multiplying a constant to a fraction, I'll write 44 as a fraction over 1 to make sure I multiply correctly. 44 times 3 is 132, and 1 times 8 is 8. I know I can reduce 132 over 8, but I could also divide and get a decimal value. Either of these options are fine, but make sure if you leave your answer as a fraction, it's in simplest form. 132 and 8 have a common factor of 4, which means a is equal to 33 over 2, or 16.5.
Wow, so solving that proportion wasn't actually any different than solving other equations. Let's try another example. 5 over 9 equals 4 over 3b plus 2. This variable is stuck down here in the denominator. We can't do anything with a variable until we get it into the numerator. How could we do this? Well, since I'm dividing 4 by this quantity 3b plus 2, I will multiply both sides of the equation by this entire expression to get b out of the denominator, which will help me solve this equation. Okay, let's do it.
On the right, 4 over 3b plus 2 times 3b plus 2 over 1 cancels this entire expression, and I'm just left with 4. On the left, I have 5 times the quantity 3b plus 2 over 9. Okay, so that accomplished the goal of getting b out of the denominator. Now it looks like I need to simplify. What can I do next? I'll distribute 5 to get 15b plus 10 over 9. Okay, what is happening to b? A lot, actually. We're multiplying b by 15, adding 10, and then dividing by 9. It might seem like a lot, but it's just like unwrapping a present. Start with the outermost layer and work your way in. So that means I want to start with canceling the 9 by multiplying both sides by 9. Now 15b plus 10 equals 36. Subtract 10 from both sides. Divide both sides by 15, and we get b equals 26 over 15. 26 and 15 don't have any common factors, so this is simplified. Great job! Pause the video and explain the steps we used to solve this proportion in the space provided in your notes.
That last proportion had a variable in an expression, but this proportion has two variable terms, one on each side of the equal sign. If you're feeling confident, go ahead and pause the video to solve this on your own. Otherwise, follow along with me.
Negative 2c over 5 equals 3c minus 5 over 7. Whenever I solve equations with two variable terms, I usually start by canceling one of them. And even though these variable terms are both in the numerator, I can't cancel either of these terms without first canceling these denominators. It doesn't really matter which denominator I start with, so I guess I'll start by multiplying both sides of this equation by 5 over 1. This leaves me with negative 2c equal to 5 times the quantity 3c minus 5 over 7. We're not ready to cancel one of these variable terms yet. Let's multiply both sides by 7. Now, we've finally canceled both of our denominators, and we're left with the equation negative 14c equals 5 times the quantity 3c minus 5. I know you can take things from here. Pause the video and solve this equation for c. Then, come back to check your work. I start by distributing this 5 on the right, which gives me 15c minus 25. Then, I canceled 15c by subtracting 15c from both sides to get negative 29c equals negative 25. Finally, I divide both sides by negative 29 to get c equals negative 25 over negative 29, which is positive 25 over 29. Pause here if you need to correct any errors or make any additional notes for yourself.
Okay, we're definitely ready to tackle this final proportion and find the height of Burj Khalifa. Let's fill in all the solutions we've found so far. Are you up for the challenge?
You can pause the video if you'd like to give this one a try on your own, or follow along with me. We've got a lot going on here, so I think we should start by simplifying one piece at a time, starting with the numerator on the left. 15 times 26 over 15 is just 26, and 26 minus 25 is just 1. Next, let's simplify the denominator on the left. First, I'll multiply 58 and 25. That gives me 1,450. Next, I will divide 1,450 by 29, which is equal to 50. Now the left side has been completely simplified. On the right, there's not much to simplify, but I prefer not to have a fraction inside a fraction. It'll be easier to work with as a decimal, so I'll write 33 over 2 as 16.5. Now what should we do? Well, in order to solve for h, I need it in the numerator, so I will multiply both sides by h. And finally, I'll multiply both sides by 50, and I get h equals 825.
Wow, so if h equals 825, that must be the height of the Burj Khalifa, and that means our puzzle pieces are numbers 8, 2, and 5. Believe it or not, I think we only have 2 more challenges before I can attempt to escape Math Lock Mansion. Thank you for your help. Today, we solved proportions, a special type of equation that is made up of 2 equal ratios. We used inverse operations to cancel terms and isolate our variable, just like we've done with all the other equations. Make sure you finish up these notes before you attempt the online practice levels 1 through 3. And remember, math is everywhere. Keep exploring.
Hey, hey.